Hello everyone, welcome to ARM Edge Computing Online Summit 2021. I'm the host for today, my name is Aya. With the rapid development of the world of compute, cloud computing, distributed cloud computing, and edge computing will all be driven by emerging 5G access networks. The amount of data that needs to be processed is up to petabytes or zettabytes. As this data needs to be transformed, analyzed, and turned into actionable intelligence in real time, the environments managed by IT organizations will extend from traditional data centers into the distributed cloud and edge environments. Ruggedized servers installed on all your rigs, cameras, sensors, and micro data centers powering smart cities, and mobilized healthcare platforms that provide patient care and monitoring are all examples of edge computing. ARM predicts the world will see up to 1 trillion edge-connected devices by 2035. This staggering number underlines the importance of edge computing. To assist its partners, ARM has announced Project Cassini, an open initiative that aims to enhance cloud-connected experiences through secure edge ecosystems. In the first half of Summit, we are very honored to invite Charlie, the principal FAE of ARM, and our long-term partner Nuvoton, a leading semiconductor manufacturer and microcontrollers, Advantech, the global leader in the field of IoT intelligence systems and embedded platforms, to take you through the technical details and the use cases. Three heavyweight experts in the industry, Mr. David Shi, FAE Director of ARM, Mr. Jason Lin, VP of MCU Application, BG of Nuvoton, and Aaron Su, AVP of Embedded IoT Group of Advantech, will join the panel focusing on edge computing ecosystem through the second half. Please don't miss out and stay tuned. Now the summit will begin. First of all, please allow me to introduce you Mr. Charlie Shi, Principal FAE of ARM. Please say hi to everyone.
Hello everyone, I'm Charlie from ARM.
Next, I would like to introduce Mr. Jason Lin, VP of MCU Application, BG of Nuvoton. Please say hi to everyone.
Hello everyone, I'm Jason Lin from Nuvoton Technology.
And now I would like to introduce Mr. Aaron Su, AVP of Embedded IoT Group of Advantech.
Good day, everyone. My name is Aaron Su from Advantech.
Thank you. Now let's welcome Charlie to introduce the exciting standard-based industry initiative Project Cassini. Charlie, please.
Thank you, Aya. It's my pleasure to introduce Project Cassini in this online summit. I would like to start from the market status of ARM. As you may know, ARM is not a silicon company. Our products are the IP of key computing units like CPU, GPU, and NPU for AI. Partners integrate our IP into their hardware system to design various chips for different applications. They are so-called ARM-based SoCs. From the first day of ARM till now, there are 170 billion pieces ARM-based chips shipped in the world, and it's about 20 billion shipped per year now. An amazing number. If we look at different use cases, CPU had over 95% adoption rate in smartphone. GPU multi-series is #1 in GPU IP vendors. Regarding to IoT use cases, over 70% rich embedded devices are powered by ARM processor. Our lives are surrounded and serviced by ARM technology, but how this device service us? Let's take a look at this network block diagram. The cloud and data center are at left-hand side, while endpoint device at right. In cloud computing era, device collect lots of data, then transmit them to higher level edge devices, like gateway or edge server. With protocol translation integration, the data transmitted to cloud side again, and have the service layer. This flow works successfully, but it met new challenge with the ramp up of end devices. 1 trillion connect devices are expected in 2035. Then, edge computing is the new trend racing in this scenario. You may ask, what's the difference between service by cloud or edge? If you have a chance to look into detail, you'll find it is the way it must happen. First, bandwidth is a big problem. If data from all devices are sent to cloud, it will swamp the network. Then data transmission is a power-hungry task actually. The farther you transmit, the more power you consume. Think a case you want to buy a pizza from chain store. Will you choose the shop in town or the 100 kilometers far away? I believe most of the people will choose the closer one to save your oil. That's the same as computing job. In different applications, there may have additional requirements to latency, autonomy, and security privacy. It's hard to fulfill all the requirements from cloud. Thus, the offloading to edge is really the way it will happen. We can see different edge use cases are rising, like the gateway for industrial IoT or smart cities. More introduction to the application will be provided later. Now, we back to the IoT ecosystem architecture with more detail to explain what's the problem targeted by Project Cassini. The design in cloud is homogeneous. Common OSs can be used on various hardware platforms, and different applications can run on top of the OS. However, it's different case at endpoint and edge side. The devices are diverse with optimized hardware to achieve performance and power target. All the software are developed for each hardware platform specifically. If a product wants to migrate to different hardware platform, the software application needs to be redeveloped again. This is a problem to offload the service from cloud to edge, as it's not practical to port the cloud-native software to different platforms again and again. The vision of Project Cassini is to build up standards to let all edge devices can run the common OSs and application with single porting only, like what have in cloud side now. Cassini is composed of three parts: standard, security, and ecosystem. The ARM system ready in yellow provides requirement to hardware and firmware with certification program. The certified device could run in cloud-native software easily. Security in blue is an important topic in IoT world. ARM PSA built up a consistency security requirement from end to cloud. In order to support security service in common platform, an open API project is developed to be the solution. The gray one ecosystem of cloud-native stack provide a common software adoption for Cassini certified devices. It's the foundation of service capability in edge nodes. Let's jump into detail of system ready. As mentioned before, the platform is diverse at edge side. Silicon vendors not only provide their chip, but need to develop the SDK for a customer to use with. OEM develop firmware and application based on specific chip, and all the tasks will repeat if they want to switch the hardware platform. This becomes the barrier to choose the hardware best fit to the application due to the concern of a software redevelopment. System ready define the requirement on hardware and the interface of how firmware connected to OS to achieve common software adoption across different hardware platforms. OEM could leverage their software design, reduce the barrier for platform selection, and silicon vendor could have less effort on SDK developing. To support different levels in network, ARM defined 4 bands of system ready based on the role and firmware implementation. The Linux boot server ready, IoT ready, embedded server ready, and server ready. Take an example in IoT ready. If you follow the BSA hardware standard and the EBBR firmware requirement, then the device can support the Fedora, Ubuntu, and Debian OS distro naturally. We also provide different certification programs for each band to make sure the support are well verified. Security is hard in IoT, no matter the data collection and transmission at endpoint or privacy in edge node. All are concerned. ARM PSA provide hardware and upper layer software requirement to guarantee device security in required level. We would like to leverage success at endpoint segment and expand it to edge side to provide a consistency security in ecosystem. Security in application is serviced by low-level hardware normally. However, in the vision of common software platform by Project Cassini, the application will no longer know who is servicing them. Project is providing in this background. Project provides open API to let upper layer application calling the microservice without carrying of hardware. The request is transferred across OS to real design and routed to the security service provider. Any platform, any architecture works. The cloud-native software ecosystem is very important part in Cassini. ARM had worked with lots of vendors for collaboration. From the page, you can see participation from different kinds of software companies, including operating system, virtualization, library, and applications. They are really providing good resources for Cassini certified device to leverage. ARM keeps work with the ecosystem to make it stronger and stronger. So these are the three main parts of the Project Cassini.
As Charlie just explained it, Project Cassini is an initiative enable our partners to break the barrier for Edge and IoT deployments. The three pillars of Project Cassini are system-ready security certification program, open API including PSA and POSIX, and the reference implementation for a cloud-native ecosystems. Next, Charlie will walk us through the details and the use cases.
Now, we would like to talk the advantage of Project Cassini to the ecosystem. From the Silicon partners' perspective, they can leverage the common OS to reduce the effort on developing of the SDK, so they can focus their resource onto the differentiation of their silicon to make a better product. For OEM, ODM, they have more freedom on the hardware selection, and there is no longer the barrier of a software porting concern. For the software vendors, if they want to support the ARM ecosystem, they only need to port in their software from cloud to the edge side once. They can port their software to meet the common platform requirement, doesn't need to port each time for a specific hardware. Then for a system integrator, they also can port their applications onto different hardware platform to match the requirement, various requirements from their end customer. For IT and OT side, they can integrate IoT device easily into their system. They don't need to care about the problem they worried before. Okay, then we can see the use cases of the Project Cassini. If you try to look at home, you may find some small black boxes, like the network router, Wi-Fi access point, or the setup box. All of these devices are designed for a specific application and by different hardware inside. Also, all the software on top of this device are different. They all defined specifically for this hardware. If you're thinking a condition under Project Cassini, if we can build up a general platform and this platform can define their functionality by different software application, it will be very easy to grab the scale of this kind of device. You can build up a single hardware platform and put the networking service when it's required, or put the video service when it's required. Then you can easily to scale this design and scale your serviceability. For the ODM side, they may meet a condition that their application need to be adopted on different level in the network, on the edge side, on the endpoint side, or in the server side. In all different sides, they have the different software architectures, so they need to develop the application again and again in previous case, in current situation. But with the Project Cassini support and benefit from the technology of virtualization, they don't need to port all the application to to every single platform. They can have a common application and adapt in each platform by the virtualization technology. It's a really good benefit to them. The deployment of the smart city is challenging because the scale, you need to deploy various silicons, various devices from different OEMs into a city scale, and also you need to have a consistent software running on top of it. Yeah. In the case you don't have a Project Cassini, you need to list down all the devices you use and develop a software to cover all of this device. And you have no chance to put new device into this ecosystem because the software doesn't support it. But with Project Cassini, you can use the various hardware platform and also run in the same application, and you also can put new device when required. So we can say this is the best fit of the Project Cassini use case. Okay, so we see the use case in Project Cassini, and then we talk about how we engage the ecosystem for Project Cassini. Now, as you may know, the Project Cassini is in the starting phase right now. We invite lots of partners and we have lots of the participation, but we also want more partners to join the whole ecosystem to work with ARM together. For the silicon vendors, it's not only use the ARM-based product, we also need your help to support the hardware requirement and firmware requirement defined by system ready. Then you can really benefit from the software ecosystem. And for the ODM, we would like to have your help to developing your application from the common OS view. Then you can easily move your applications to different hardware platforms and reduce your effort. And also for the software ecosystem partner, we would like to have more engagement with you to introduce more cloud software application to the edge side and provide a stronger edge node. So we hope to work with you together to make this Project Cassini more important. Now we get a recap of the Project Cassini. The purpose of Project Cassini is to ensure a cloud-native software can be used in the ARM edge ecosystem. So how we can achieve this is by 3 items. We define the hardware and firmware standards, and if you meet the standards, you can leverage the software ecosystem. You don't need to develop software for every hardware platform. And then the second part is the security. We provide a security standard, PSA, to define the hardware and the upper layer software requirement to make sure a consistency security level across the devices. Also, we provide a parsec to mitigate the security resource calling in a Project Cassini-based common platform. And the last one is the software ecosystem. We are inviting more partners into the software ecosystem to make the Project Cassini compliant device can use more resource. So this is the introduction of Project Cassini. Thanks for your listening.
Next, I would like to welcome Mr. Jason Lin, VP of MCU Application, BG of Nuvoton, to share his perspective on AIoT, the solution and the use case.
Okay. Hello, everybody. I am Jason Lin from Nuvoton Technology. Today, I would like to share the AIoT use case from Nuvoton point of view. First of all, I would like to have a brief introduction about the Nuvoton. Nuvoton, by be a hidden champion in providing sustainable semiconductors to enrich human life as our vision statement. Yeah. Nuvoton is spin off from the Winbound Electronic Logic Business Group at 2008, and we IPO in 2010. Now the capital is about 3,759 million NT. Yeah. And after the acquisition of the Panasonic Semiconductor in the last September, now we have 8 worldwide office, yeah, for the RD and the sales, yeah. Headquartered in Hsinchu Science Park, yeah. Then we have RD and the sales office in San Jose, Israel, Japan, then Korea, Singapore, India, and China. Then I will talk about our Nuvoton microcontroller and the microprocessor portfolio. We introduced the 8051 traditional microcontroller in 1992. Then we have ARM9 in the year 2000. And then we introduced the M-Rail microcontroller in 2009. And we are the worldwide number 2 to release the M-Rail microcontroller. And then we are the number 1, the first one, yeah, to release the M-Rail microcontroller into the mass production. In 2012, we released the M4 MCU, and then in 2016, we released the M22 based microcontroller for the IoT security. Now the M2351 passed the PSA Level 1 and Level 2 certifications. Yeah. And recently in 2019, we started developing for the IoT gateway microprocessor based on the ARM Cortex-A35. Yeah. In this slide, I show the Nuvoton microcontroller portfolio from the entry level to the very high levels. So you can see that we have an entry level 8051 microcontroller, then the Cortex M-Rail for the mass market, and the M23 for the IoT security, then the Cortex M4 based microcontroller for the high processing power microcontroller, then the ARM9 and the A35 for the IoT gateway applications. And then I will talk about in the embedding processing trend. Yeah, I think for the current emerging IoT applications, I think most of them are the embedded applications, and they need the embedded processing, and the processing power provided by the microcontroller and the microprocessor. So I think the market is keep increasing, and in this market, I think there are some technical demands. First one, they're requesting of the much lower power consumption. Then we also need the efficiency of computing power. Then the security and the safety are the mandatory requirement for the future IoT device. And the software running on this device are getting important. So in the traditional way, we choose a microcontroller or microprocessor. We will check out what kind of the peripherals, then how many pins, and how many memory that we need to do the device. But in the current IoT trend, yeah, first of all, we need to think about what kind of system architecture they can provide a low power, high efficiency, also provide a security and the safety. Then in the development environment, we also need to think about is the development environment provide the easy development environment, also the security function built in. Then we would like the application to run to be able to run on multiple platforms. So this is the Nuvoton perspective on IoT device, because we are a long time experience in the microcontroller business. I think the IoT device in traditional business, there is an IoT device for dedicated functions. It may be run on proprietary protocol, be to have simple functions. But now, as the IoT business booming, a lot of the devices would like to connect to a public wireless network. Yeah. So the new sensor nodes, they would like to acquire the data to have a more accurate processing. But the connectivity would like to use Wi-Fi or Bluetooth. Then we have now another trend is the sensor hub. It's just because the using environment is getting complex. So the sensor node need to have a connect to multiple sensors to have the computation and doing the local intelligence and transfer the processed data sent to the intelligent gateway. So there's the sensor hub. And in the gateway, there are lightweight gateway and a high processing gateway. And usually is the M4 for all the MPU, they can do that. Because they need the local processing and some kind of the machine learning intelligence on this device. Finally, this processed data will transfer to the cloud or server for data storage or processing. Then the users can use their mobile device to check the data or monitoring the status on that and do the required control through the cloud server to the sensor nodes. I think this is the Nuvoton IoT ecosystem. Yeah. First of all, we based on Nuvoton rich portfolio on the MCU and MPU, and we take the low power security and the high processing as the core technology to implement the edge device connectivity, router gateway, and the cloud server solutions. Yeah. So we provide first of all, we provide a device platform for the edge device. They can run on the real-time operating systems. Then we have a driver ready for the connectivity, such as LoRa, Wi-Fi, and Bluetooth. Then we have a gateway platform to be used for the gateway applications. Then it may be run on Linux or run on ARM embedded by the Cortex M4. And we provide a cloud-ready application development environment. So on that we have a set of software that can support different cloud connection like Pelion, AWS, and Microsoft. And finally, we provide another companion application. They can be executed on a mobile device to do the real-time monitoring and the control. So based on the idea, so you can see that Nuvoton provide several set of application development kit. Also, we have a platform and the software to support the sensor node, sensor hub, smart gateway, also the AI and the cloud software. Yes. So from that you can show that we have a M0 platform, we have M4 platform, we have an ARM9 platform, and the company software to service all of the IoT requirement. This page shows the Nuvoton ecosystem. Yeah, I think for ecosystem, you need a chip, then a hardware and a software, and finally some of the supporting material for this ecosystem. So we based on the Nuvoton rich portfolio on the microcontroller and microprocessor. We provide a good development platform by the BSP, software tool, also debugging tool, and the development environment. Accompanied by a reference design platform for gateway, DALI, and especially we have an IoT platform to support multi-cloud, multiple connectivity to connect to multiple cloud applications. Yeah, and all of this data we can get them. User can get them through our Nuvoton nuvoton.com, the website. In the website, you can got all of this the developing material. Also, you also can buy the chip and the evaluation board from this website. Yeah. Now we back to the Project Cassini, because for a silicon vendor, I think to serve the diversified application for the IoT, you need a good development environment or the ecosystem to support it. Yeah. So we work with ARM about Project Cassini, and Project Cassini provider. First one is the ARM system ready. For system ready, it provide a hardware and the software specification to have a minimal requirement. Then have a parsec to support the PSA label certification. Also an open API to do the cross-platform developing. Finally, they also provide a cloud-native stack for easy to connect to the cloud and developing cloud-native applications. I think for the Nuvoton IoT ecosystem and the Project Cassini, we are based on the same goal to provide a good developing environment for future IoT need. So first one, from the system architecture point of view, Nuvoton has a rich experience on ARM platform. We also have a very good service knowledge and application knowledge on that. So he adapt to the ARM system ready to have a hardware and software certification. I think it default should be okay. Yeah. Then talking about the development ecosystem, especially on the security, Nuvoton has rich experience, and we work with ARM on the PSA certification. And we have M2351 to be a PSA level 1 and level 2 certificate. And we also deploy this technology into our new microcontroller and the microprocessors. So if you feel the idea of on the parsec, the idea to have a cross-platform security API. Finally, Nuvoton provide a lot of application software to let customer to easy to connect to the cloud and develop the cloud service on that. So it's compared to ARM to provide native cloud native stacks. We also based on the same goal to provide the same easy to connect to cloud applications. So based on these three ideas, I think Project Cassini is a very good platform for future IoT environment, especially the first one on the system ready, then parsec, and the cloud native API. Yeah. So Nuvoton will keep working with ARM on developing a new development environment according to Project Cassini. Yeah. Thank you. This is my presentation. Thank you.
Next, I would like to welcome Mr. Aaron Su, MVP of Embedded IoT Group of Advantech, to introduce the use case of AIoT.
Sure. Good day, everyone. My name is Aaron Su, the Associate Vice President of Advantech Embedded IoT Group. I think we're all agreeing that the IoT and AI application is going to bring a big impact to our life. And ARM is no doubt the key technology to enable more IoT and AI application in the world. So today, I would like to share with you the Advantech point of view about how to enable the ARM technology in the IoT application by standardization and cross-field cooperation. First of all, I want to share with you the key technology in the embedded application. ARM and ST is the two key technology for the embedded market. ARM technology with a benefit on the low power consumption and the compact design. And x86 can provide a benefit of computing power and the peripheral and software integrations. So in most of the case, the ARM technology is implemented as an end device of the IoT applications and corresponding to the IoT requirement very closely. And the x86 technology is implemented at the back-end side of the application and take the function of power data computing and analysis. However, because of the rapid growth of IoT and AI application, it generated a great demand to the end device and edge computers, and gradually moved the ARM technology to the upwind side of the IoT applications. So, for all the IoT service providers, I think you need to understand the trend of ARM technology and start to thinking about how to improve your IoT application value by adopting ARM technology. Actually, the demand for ARM technology is come from three directions. For the first type of customer is a customer adopt the ARM technology already at this moment. The major difference is in the past, they are doing the in-house design. But because the requirement of low power consumption, they want to improve the resource utility ability, they will move to the ARM technology by outsourcing. And the second type of customer is the one using x86 technology now, but because of the requirement of low power consumption and embedded OS, like Linux, they will adopt ARM technology in their future applications. And the last demand is for the edge computer and end device that I just introduced in my previous slide. Is called by the delivery goals of IoT and AI applications. But no matter which kind of demand, all of the IoT service providers, they face the same issue of a resource investment when they want to enable ARM-based project in their applications. The reason why the resource is difficult to invest is related to the highly alignment between the end device and each IoT requirement. So it makes the software design of each ARM-based application is very diversified. And the software integration, the driver integration is not as easy as x86. All of these challenges make the people hesitate to adopt ARM technology. So in order to improve this situation, I think we need to enable more collaboration and more standardization on both hardware and software side. I think this is also the reason why ARM want to promote aggressively of the Project Cassini in the market, because they want to improve the situation of ARM technology in all application by standardization. Based on the standardization and the collaboration concept, the standard product provided by Advantech provide 4 advantages. The first advantage is we are able to provide a product with the latest technology from a silicon partner. So the product with NXP i8 in this year is a very good example. Second, Advantech also provide several open standards and open industrial standard products like SMART, Q7, Pico IDX to align with the different I/O requirements of customer IoT applications. And except hardware offering, we also provide a series of standard software service to help customers to build out the embedded Linux and the application feature they need for their IoT applications. And Advantech is also able to create more value and service by the cross-field cooperations. In the future slide, I will introduce each advantage in more detail. About the leading technology, actually, Advantech keep many close collaboration with the major silicon provider like NXP, Rockchip, TI, and NVIDIA. The technology cover from the Cortex-A8 up to the Cortex-A78. And we are able to provide a different performance level and the different I/O configuration solution to customers' IoT applications. And we are able to make sure almost all the IoT application that start from like a small machine controller up to the AI or server application can find the best fit ARM technology to optimize their code structure and performance of their IoT applications. I think it's a clear commitment for Advantech to keep adapting the latest technology into our product and help a customer to benefit from those new features and performance by the new SoC in their applications. For standard product, as we all know, standard product can provide the benefit on the low entry barrier and fast time to market. Because for standard product, customers don't need to pay the NRE, and they don't need to do the computable design by themselves. According to the different requirements of a different IoT application, Advantech provides 3 kinds of major standard products: computer module, single board solution, application-oriented box solutions. For computer module, it's suitable for the customer which require a unique feature and vertical I/O. So they can direct adopt Advantech's computer module on top of their vertical I/O board, and the hardware design is done. And the project is ready to go. And for the customer, they want to minimize the hardware design and to more focus on the system integration by a ready-to-go single board solution. So Advantech single board solution can be their best choice. And for the customer, is more willing to focus on the IoT software value. With an application-oriented, ready-to-use system solution, it allows customers to minimize the integration job and focus all their resources on the IoT software development and increase the overall competitiveness of their applications. Except the hardware solution, the software development is always the most important thing for customers. So Advantech also provides our standard software service named the AM Linux. AM Linux is released to help customers to build out the embedded Linux and provide the embedded features they need for their applications. AM Linux contains 2 major parts. The first part is Unified Embedded Platform BSP, which contains the component need for building up the embedded Linux, like a kernel, I/O, driver, utility, and APIs. And we also pre-integrate and pre-test the Unified Embedded Platform BSP with Advantech hardware solution to make sure the customer application based on Advantech hardware is able to get the best performance for their applications. And this year, we also implement the ARM BSA structure into our latest i.MX8 solution into the Unified Embedded Platform BSP. So it can maximize the versatility of a customer application software when doing the migration from the old SoC to new SoC. The second part for the AM Linux is Application Add-on SDK. It provides a useful embedded feature for customer IoT applications, such as Facebook, changing logo, and security features. And customers don't need to spend the time to do those applications by themselves. They can direct adopt the feature and improve the time to market of their overall applications. So I think the purpose of AM Linux is to help customers to speed up the time to market of their product and implement more ARM technology in IoT by standardization and reusable software services. Except the embedded Linux and the application API, we also provide a standard software utility named Voice Device ARM. It can provide a lot of remote management, control, self-monitor functions, such as remote power on-off, change screenshot, self-monitoring, and doing the in-time monitoring and the notification features to help customers to build up a reliable edge computer working network. So with the Voice Device ARM, we are able to increase the overall operation efficiency of a customer's IoT network and increase and reduce any possible risk caused by the device fail to work. The last method Advantech to speed up the ARM technology in the IoT application is by the cross-field collaboration and provide a new feature to help customers to fulfill their new demands. The program now we work with ARM on PSA for security IoT gateway is an example. With a PSA-based IoT gateway, customers can benefit from the feature like a security boot, update the driver, rollback the driver, and set a different protection level for a different device. And it can also avoid unauthorized operation to the IoT gateway on the software and setting. So with the ARM PSA structure, it provides the function that need to build out a reliable IoT gateways. And all the IoT gateway comply with the Project Cassini design guideline can easily implement a PSA into their IoT gateway and get us a security protection they need. So this is an example to show how Advantech and ARM work together to enable more ARM technology in IoT by the standardization and the cross-field cooperation. I think just as I mentioned at the beginning, AI and IoT is going to bring a huge opportunity to our life. But there are still many difficulties we need to overcome. But the standardization and cross-field collaboration can be the way to help customers to enable more ARM technology in your application. So I hope after this presentation, you can have more understand the situation of ARM technology and start to adopt the ARM technology in your application. Thank you.
Next, we'll enter the second half of Summit. In a panel discussion, you can hear the view of 3 industry experts with regards to edge computing and how to ensure secure IoT deployments through a well-connected edge ecosystem. Now, let's introduce the 3 panelists. First of all, please allow me to introduce you FAE Director of ARM, David Shi.
Hi everyone, this is David Shi from ARM.
And next, we would like to welcome Mr. Jason Lin, VP of MCU Application BG of Nuvoton.
Hello everyone, I'm Jason Lin from Nuvoton Technology.
Next, we would like to welcome Mr. Aaron Su, AVP of Embedded IoT Group of Advantech.
Good day, everyone. My name is Aaron from Advantech.
Hi everyone, my name is David Shi, FA Director at ARM. In 5G and IoT era, connected devices are growing at a very rapid rate. Everyone believes that there are huge business opportunity there. However, along with the increased network and device complexity, we also face some challenges like expensive investment in IoT infrastructure, security and privacy, low latency requirement for real-time application, etc. Those challenges drive the shift of data storage and the data processing from the cloud to the edge. Cloud-native technology could facilitate this transition by making it easier to deploy and new tasks and services across diverse, secure ecosystem. Nuvoton and Advantech are reputable companies in the industrial and have long-term relationship with ARM. Today, we are very honored to invite Mr. Jason Lin, Vice President of Nuvoton's Microcontroller Application Business Group, and Mr. Aaron Su, Associate Vice President of Embedded IoT Group of Advantech, to share their view on cloud-native ecosystem. Jason, from IC provider's perspective, could you please explain what is the typical cost incurred by supporting multiple OEM ODMs and ISV?
Okay, yeah, that's a very good question. Yeah. Yes, our customer usually to request different BSP to run on different operating systems. Yeah, and sometimes they also need the different device driver to run to use on different connectivities. Yeah. So providing BSP is a common practice for MCU or MPU vendors. Yeah. We, according to their requirement, we deliver the different kind of BSP and different operating system. Like we provide the BSP like based on the ARM embed, Linux, Amazon RTOS, and Microsoft's one. Yeah, and but on the other way, because currently in the IoT era, a lot of connectivity options. So we also need to provide a device driver like Wi-Fi, Bluetooth, BTLE, also like LTE, other things. Yeah. So based on this requirement, we need to provide a lot of different operating system, different connectivity module, also the software to connect to the different cloud. Yeah. So from Nuvoton point of view, we need to several teams to provide different solutions to different customers. So from there, you know, the supporting effort to different OEM, ODM, or customers, the supporting effort is, I think, is very, very high. Yeah. Okay. Yeah.
Okay. Thank you, Jason. So next question is to Aaron. So Aaron, the OEM like Advantech.
Yeah.
So what is the cost incurred or support required, when you use chips coming from multiple vendors in your product?
Okay. I think unlike a x86 solution, most of our ARM-based SoC solutions are designed for a certain market and certain application. So this means the multiple SoC solutions are needed to fulfill different market demand. From the hardware design, I don't think the multiple SoC will cause a big difficulty to the platform provider like Advantech, because most of the multiple SoC, they follow the standard hardware interface, like a PCI Express, USB, and the DDR4 interface. The major challenge of the multiple SoC will be on the software providers, IoT software providers, because like Advantech, we need to provide a lot of different kind of BSP support from the different SoC vendor, and also need to provide a different embedded OS to power on the different SoC solutions. And the same challenge also happen at the IoT service provider side, because if they want to get a higher performance, they want to move their solution from one SoC to another new one, and they will find the software design for the original SoC may not able to run on the new SoCs. So it will cost a lot of effort and time for the platform provider and IoT service provider to adopt the new SoC solutions. So I think this is also the reason why the ARM want to promote the Project Cassini, try to unify the software design and the solution for all the SoC solution. So we are able to minimize the effort need to enable a new SoC solution on ARM-based project.
Okay. Yeah. Thank you, Aaron. In addition to the challenge of working with different vendors to meet different type of customers' needs, there must be more challenges in edge compute deployment. Jason, could you please share with us what are the key challenges you face in deploying edge compute at scale?
Okay. Also, I think as you know, the IoT market is a very diversified market. So there are many devices for different purposes, yeah, and deployed in different environment, yeah. So first of all, I think that for deployment, first of all, I think the first one is the requirement, then designing and the porting. The second one should be the security deployment into the market, how to make sure this device is working on a very secure environment, yeah. So I think this is the major tool we need to consider when we deploy the IoT device into the field. Yeah. Okay. Yeah.
Thank you, Jason. Aaron, could you please also share your observation?
Okay. I think the major challenge for the edge computing deployment at scale is how to minimize the software design effort at each project across the different SoC solutions, such as building up an operating system, driver integration, and enable the feature like security and enable the graphical recognizability features. And unifying the software design as a standard should be the answer for this. And ARM-based system architecture provide a general guideline for the hardware required to build up an embedded system, and it's able to make a more SoC is able to run on the same operating system and same application system software. So with the ARM BSA solutions, we are able to minimize the software need we need to input for enable new ARM-based applications. And at the same time, Advantech also provide software service we call the AM Linux. It helps customers to build up the embedded Linux and integrate the driver and peripheral, and also provide the embedded feature need for their IoT applications. So I think both for the ARM BSA and ARM and Advantech AM Linux, we are trying to minimize the device effort of the ARM-based project by standardized and reusable software services.
So there are many standards be defined in the industry. Standards ensure that the compatibilities between products come from different vendors. However, too many standards could increase design complexity and the cost. Jason, please share your view on why a minimum set of standard is important to a silicon vendor.
Okay. As you know, for each chip developing, usually it takes 18 to 24 months to do the developing. Then when the customer got the chip to do the developing, it maybe need another 6 months or 12 months. Yeah. So the current in the design stage, the chip need to fill the requirement or maybe 3 years later. Yeah. So if there is a minimal requirement, yeah, or minimal set or specification for hardware and software, they will reduce the risk of the chip developing. Also, it can fit the future need of the customer need. Yeah, so I think a minimal set standard is very important to the future of our IT world. Yeah, yeah. Okay, that's my opinion. Yeah.
Yeah. Thank you. Your answer. Okay. So agree with Jason that proper standardization will benefit to not only silicon vendors but also software developers, OEM, ODMs, and system integrators. In response to this unannounced Project Cassini initiative in 2019, it's built on 3 foundational components. The first one is robust system-ready program. Second one is security APIs and the microservices validated by certification program. The last one is reference solutions like make cloud-native stack a part of edge development. Project Cassini makes it easier for developers to use cloud-native technology such as service-oriented architecture, container orchestration, and the continuous integration and the continuous delivery pipelines. To streamline development and accelerate development, Project Cassini also makes it easier for software vendors to offer portable solutions that are easy to integrate into a large system and run without modification on every device. This is especially important in large-scale deployments, such as smart cities, where centralized entities manage a wide range of services and applications across multiple, widely different devices, gateway, or microservers. Security is also an important topic for IoT world. We would like to ask Jason and Aaron to talk about how do you address IoT security concerns and what you want to help establish a security baseline. So, Jason first.
Okay, yeah. Okay, I think security is one of the core technology of the Nuvoton. Yeah, I think it's also the mandatory need for the future IoT world. Yeah, I think back to the 2016, we start to develop the first IoT security MCU, M2351. On that time, there is no IoT security standard layer. Yeah, so we work with ARM, yeah, to define a set of the IoT standard. But we worked for several years, and then finally ARM defined a PSA. Yeah, so our M2351 already passed the PSA level 1 and level 2. Yeah, and they can then our customer know what's the security security label now this device have. Yeah, so it is very to do the right judge or to choose the right microcontroller for their own use. So I think a security standard, I think, is a very important for the IoT world. Yeah, to let our customer know what kind of security label do they need to have, or do they need to use? Yeah. Okay.
Okay. So good to know. Nuvoton already have product pass PSA certification. So Aaron, please also share your view about security in IoT world.
Okay. I think security is always the most important topic to all the customer. Unauthorized operation can damage to the whole operation and cause a huge loss to customer operation owner. But pure hardware or software design of security is not the best solution for all the customers. The best solution is the security integrated with the hardware and software design. But it's not easy for customers to build this kind of security solution by themselves because there are too many hardware and software design are involved. The best solution for customer is to provide a ready-to-use, well-integrated IoT gateway security solution to them. So Advantech already worked with ARM from 6 months ago. We kick off our first IoT gateway, EPC R3720, which is pre-integrated with ARM PSA certifications. So it can provide a very reliable, comprehensive security solution for customer to fulfill the IoT security requirement. And with ARM PSA, it provides a lot of security features for the IoT security gateways. Stuff like security boot, data protection, and driver update or rollback. And it can also allow the customer to set a different security level based on a different device of life cycles. So it can help customers to build a reliable and safety environment between their IoT gateway and their cloud services without spending their own resources to build all the security features by themselves. So again, the certification, security is always the most important topic for all the IoT application providers. And the BSA provide an open, reliable, easy to enable, and continuous update the IoT gateway security solution to the platform provider like Advantech to help us is able to build up a hardware and software integrate IoT security solution to enable more IoT application in the world.
Okay, we hope we will see Advantech's PSA certified gateway in the market very soon.
Yes.
Yeah. Okay, so the reason why ARM rolled out a PSA certification program and the open source platform abstraction for security, we call it PASIC initiative, is to enable customers to raise the security level for their products, as well as to provide a common language in IoT world to address the requirement of security. These two initiatives ensure a baseline of security for all connected devices. PSA offers a security framework and the certification scheme that give an objective assessment of the quality of the implementation for the device root of trust, thereby establishing a foundation of trust on which to build. The open source PASIC initiative provides secure root of trust abstraction and the common runtime security service for application in a platform and architecture-independent manner for application-wide security. Apart from security, Aaron, we know that Advantech is a leading company in IPC, and the gateway is a key device for industrial applications. Please, can you share about how do you manage putting your workload and the customer application on different gateways?
Okay, for the non-Windows-based IoT gateway, such as use Linux, the operating system is built based on the customer application requirement and is closely linked to the application software. There is no clean rule to identify which job should be done by Advantech and which job should be done by the customers. With the multiple SOC and the diversified software requirement of each application, all of this means the IoT gateway software development become a complicated job, and there is no guarantee the resource put on one project is able to leverage it to another one in the future. Standardized software of IoT gateway should be the solution to improve the collaboration between the platform provider and the IoT service provider. But IoT service is hard to standardize. There is no way to unify the feature for the medical and the transportation applications. So the most likely way is to provide a standard and reusable platform software package, such as unified kernel, driver, utility, application API structure, and the interface to maximize the capacity of supporting the different kinds of IoT applications. The invention for building up this platform software package is big and require a lot of external cooperation. But the result will be remarkable and fundamentally improve the cooperation model between the platform provider like Advantech and the IoT service providers.
Okay, thank you, Aaron. And I believe Advantech will be a key driver to realize IT and OT convergence. Okay, this is my final question. It's about IT-OT convergence. As we know, typical OT network are comprised of switches, monitors, sensors, valves, and the manufacturing devices managed by an industrial control system through remote terminal units and PLCs. Since these systems manage sensitive environments, they have traditionally tended to be air-gapped from IT network to avoid IT network crash. However, things are changed. IT and OT convergence is getting started. Advantech has a remarkable market share in industrial PC and the related field around the world. I would like to ask Aaron to share your view on how does the convergence of IT and OT domains affect your business strategy, and how do you support it?
Okay. Indeed, I think IT and OT are two key elements for all the IoT application because the data curation and the service delivery rely on reliable IT structures. But OT and IT are the two different segments with a different core technology and working model. It makes the OT and IT device to be two independent systems. To enable IoT application, service provider need to set up an IoT gateway and an industrial switch or router for collecting and processing the data, then send the result to cloud. More devices involved mean higher cost and service stop risk caused by the device fail to work. Recently, we receive more and more market demand for IT and OT integrated IoT gateway solution. I think it will just be the market trend in the near future. But maybe happen step by step start on silicon solution ready. Because most of IT and OT SoC now in the market are separate offering. But I hear some of the SoC providers see the same market trend and already plan to provide a new generation of SoC integrate both computing power and networking management capacity. I think the more SoC solution will be ready in coming years. And then, of course, Advantech to be one of the leading IoT platform providers in the world. We will launch the corresponding product to improve the overall operation efficiency of our IoT applications.
Okay, thank you, Aaron. So from Aaron's answer, we know that to realize IT-OT convergence, it should start from SoC support.
Yeah.
So Jason, would you like to share your thought as well?
Okay, yeah. As a vendor of embedded processing, like a microcontroller and microprocessors, I think the embedded processing product can be used IT, OT, also the data technology. Yeah, it's coming. Yeah. So for embedded processing vendors, I think first one we provide a rich portfolio of products like MCU to high processing microprocessors. Second, we are very focused on the ecosystem or the developing platform, and with the security built-in to provide the future need for the IoT, because the application is very diversified, so it need a very good development environment to support them to do their innovative products. Yeah. So I think the convergence, yes, it is coming. Mm-hmm. Yeah. But we hope Nuvoton can provide a rich portfolio and a good ecosystem and provide a good, very excellent of this the development environment for this market. Yeah.
Okay, we look forward it too.
Yeah.
Okay. So Jason and Aaron, thank you for sharing your observation and your viewpoint today. So could you please summarize the key points of your talk? Start from Aaron.
Sure. No doubt, I think the deployment of IoT will bring a big improvement to the people's life. but I think it will obey impact to our existing concept and the model we are operate now. So we need to enable more rule and standard through the horizontal and the vertical collaboration to respond to the challenge brought by the development of IoT. Then we can truly land the IoT application in every corner of our life. ARM is the key provider of IoT core technology in the world. So Advantech is looking forward to collaborate more with ARM in the future to complete the IoT ecosystem and speed up the deployment of IoT application in the world.
Thank you, Aaron. Jason.
Okay. I think the first one, within the goal of the Project Cassini is to provide hardware, software standard by the system ready. Yeah, they need a PASEC to provide a certification, also a security API to across platforms. Yeah. Finally, it provide advanced design or native ready stack for all the new applications. Yeah. I think it's the same goal as Nuvoton. We provide all our development platform just want to let our customer can be very easily to develop their application on that without the concern of the underlying hardware, also the security. Yeah. So I think we will work with ARM, especially on the Project Cassini, to provide a good and a new development environment for the new IoT application business. Yeah. Okay.
Okay. Good to hear positive feedback from Aaron and Jason about Project Cassini. In today's panel discussion, we talk about the challenge, change, and the change in edge compute. Through the conversation, we found it's critical to have a consistent foundation on which to build, so developers can focus on the value that comes from creating deploying new workloads and the services with single code base. Project Cassini is an open, collaborative, standards-based initiative to deliver a cloud-native software experience across a secure on-edge ecosystem. With the solution built on Project Cassini Foundation and provided by ARM ecosystem partners such as Nuvoton and Advantech, the leading SoC companies and the supplier of IoT embedded platform, developers can move quickly from prototype to production, and it will be easier to port software, reuse code, enable continuous development, and deploy faster. Over the past few decades, ARM has offered innovative solutions and initiatives to build a huge ecosystem to provide support in hardware, software, technology, design service, and tools, which has significantly reduced developing time and cost for our clients. ARM and our ecosystem partner will continue to innovate and invest in software and hardware development to drive transformational change. Thank you for joining us today. See you next time.
As computing moves from the cloud to the edge, ARM IP and ecosystem are becoming increasingly important to the Internet of Things, the industrial Internet of Things, and the network market, apart from laying the foundation for the expansion and success of the edge computing. In the new way of IoT application accelerated by 5G, we believe that ARM's edge computing ecosystem will be the right choice for your advanced deployment of Internet of the Things at the edge. Thank you for watching. We will see you next time.